Hello, my name's Bob Thorne and I'm a Senior Applications Engineer here at Radan. Now today I'm here to tell you all about the latest release of Radan CAD/CAM software, Radan 2017. Now as with all releases of software, we've introduced new features and functions across the whole range of Radan product. Now unfortunately I don't have time to show you every aspect of the new release, so what I've done is picked out some of the highlights, and I've detailed some of the features and functions in this video. So please have a look and enjoy. In our continuing drive to improve the Radan CAD/CAM system, we have launched Radan 2017. Now to get the best from your hardware, it has been necessary to drop support for 32-bit operating systems. So Radan 2017 will not run on a 32-bit operating system. There is, however, a limited 32-bit Radan application for DNC PCs. As with all new releases of Radan software, we update our import and export formats. 3D import formats. The table in front of you shows the file types that we can read into Radan 3D. In the second column you will see the file extensions associated with those file types. Columns 3 and 4 show the minimum and maximum versions of that file that can be read in to Radan 3D. Now, important column on the end there, marked material, shows whether or not that file format will actually include material, and we can then read that material in Radan 3D. .3D export formats. The table in front of you shows you the file types that we can export from Radan 3D, again with the associated file extensions. Columns 3 and 4 show you the minimum, maximum versions that can be exported. And again, the column marked material at the end indicates which file types will include material when exported. .3D graphics. Radan 3D is now using a more modern version of OpenGL, which improves support for more graphics cards. At the same time, the performance of highlighting has been greatly improved, making working in 3D and selecting objects more efficient. .3D axis colors. The colors used to depict the 3 axes in 3D are now user definable from the View Settings dialog. By selecting Define in the Colors option, the user can specify unique color for the X, the Y, and the Z axes. Let me show you this in 3D. So here in my 3D session you can see that each of my axes are the same color. Now, to make it easier to work in 3D, it would be preferable for me to be able to identify each axis by a different color. So by going to the View Settings, and then select in the color option Define, you can see that there are 3 new options now to define a color for each of the X, Y, and Z axes. Improved model manipulation using the 3D side panel. The 3D side panel was introduced in Radan 2016. The side panel can be very useful for manipulating imported models and assemblies, allowing you to very quickly get to the parts that you to manipulate. In Radan 2017 we've also added several useful commands to a context menu. Object Detail Tooltips. By simply moving your cursor close to an object in 3D, you will now be presented with a tooltip which gives you information about the part, its material and thickness. Now before I go into 3D, you can see here that the side panel can be very useful in editing and manipulating 2D drawings as well. By simply selecting the tick boxes, I'm able to control the visibility of the layers and patterns within the drawing. If we now go into 3D and switch on the splitter window, you can see that in the side panel I've got a lot of information and details about my assembly. By selecting components in this side panel, I can very quickly turn on their visibility, change their material or color, In Radan 2017 we've added many useful commands to a flyout context menu. By simply selecting the part and right-clicking, the context menu is displayed. Also new in Radan 2017 is the addition of model details supplied in tooltips as you hover close to the model with your cursor. "3D default views." Now for me this is a great addition to Radan 3D. It's a very simple enhancement, but it speeds up the process of getting exactly the view that you want of your model. By using the keypad, the user can quickly view the model from one of a standard set of view angles. Let me show you this in action. You can see with my model on screen, I simply press one of 6 different keys on my keypad to generate a view of the model corresponding to that number. Converting 3D parts. When we import parts from a third-party CAD system, such as STEP or SAP files, we lose the history tree from the original CAD data. Therefore, it's very difficult to edit a sheet metal model. So if we wanted, for example, to edit the material thickness or a bend angle, this is very difficult. In Radan 2017, we've added a command to the context menu which will convert an imported model into true sheet metal features, allowing us to edit that part. This is a great piece of functionality, so let me show you it in action. So here I'm going to import a STEP file. And here we have a simple sheet metal STEP file. When I go to edit perhaps the material thickness, and here I'm going to change it from 3mm to 1mm. You can see here that the model doesn't change. This is because the model has no sheet metal intelligence. If I go to the feature list and have a look at the features in the model, you'll see that there's just one feature, which is the imported part. So, using my new option in my context menu, if I select the model, right click and go convert to sheet metal, outwardly nothing changes, the model looks exactly the same. But if I now go to the feature list, you'll see that I've got a complete list of sheet metal features, all of which I can now edit. If I try my original edit of the material, again changing it from 3mm maybe to 1mm, you can see that I've now been able to edit that model. I'm just going to select undo and take this model back to its original 3mm thickness, and now I'm going to have a go at editing some of the features. So you see, by selecting the face, I'm able to change the angle at which that face is applied to the model. Equally, I can select a bend and change the bend radius. And finally, I'm just going to change the angle of this face. But you can see it's a very powerful feature, allowing me to edit imported 3D models. I just want to show you this one more time. This time I'm going to import a SAT file. So here you can see I've imported a 3D sheet metal SAT file. Now, at side panel, you can see I've just got one part in my 3D space. If I go to convert to sheet metal, I get a warning message to say that Radan 3D have to simplify this model in order to convert it. In doing so, it's created a copy of the original file so that I can always go back to the original imported model. So let me just show you the differences between the imported model and the converted model. So this is how it looks from the original file. Now, in order for Radan 3D to convert it to sheet metal features, it's had to simplify the corner. And you can see there the simplified corner detail. But this still gives me the functionality to be able to edit this model. So by simply selecting on these faces, I'm able to change the angle of each of these flanges, opening up the model. This really is a great piece of functionality, allowing me to edit imported third-party CAD files. A great new feature for those of you that have our Radan software is the ability to adjust the bends on a 3D model to suit the tooling that you have on your press brake. Again, this is accessed from the context menu. So simply select the part and then adjust the bend. So let me show you how we do this. So I'm going to design a very simple sheet metal panel. Just add a couple of flanges here to give me a sheet metal tray. Now, as a designer, I'm not really thinking about how I'm going to bend this. I'm simply designing what it is I need to actually build in sheet metal. So let's have a look at the bends and interrogate the internal bend radius. So you can see here I've got a 1mm internal bend radius. So using my context menu, if I select the model, right click and then say adjust bends for tooling information, what this does is it goes off and interrogates my Radan tooling database and then adjusts the 3D model to suit the tooling that I have on my default press brake. If I now re-interrogate that bend, you can see that it's adjusted the model to suit the tooling that I have available to bend this particular material. Now this doesn't take out a Radbend license, it just merely interrogates the Radbend database, allowing a designer to ensure that the part he has designed will in actual fact bend on your default press brake. On top of that, it has updated the develop blank so that when I actually punch or profile this part, I will get the correct size component. Profiling. Common cutting and tags. Radan 2017 now offers improved support for tags on common cut groups of parts. Automatic tooling will now add midline tags on the periphery of a common cut group of parts. It doesn't actually do it on the common cuts themselves. This, however, can be added manually. Automatic order and manual order now support midline tags on common cut groups of parts, and also corner tags on non-common cut slots of common cut groups of parts. Okay, let's show you this in action. So here I'm going to recall a project that has some parts that I want to nest, and I'm going to common cut these. So if I just show you the details in my project here, you can see that I've nominated that some of these parts are to be common cut. I've also set my auto tooling to add tags to the outside of these components. So let's have a quick look at what we've got. So you can see here that I've got a tag in the appropriate location on the outside of these parts. Now I'm actually using T-datums to force the tag to a certain location, so you can combine T-datums to ensure that the tags are in sensible positions. Now although I've placed T-datums on the edges here that are common cut, because they're common cut, the software has not put a tag. So I can now manually add a tag along the common cut lines. See, I'm just taking the lead in off of this particular tag, and I'm going to manually place this tag on the common cut lines around my components. Now this will ensure that all of these components are tagged together. I'll just zoom in and show you the tag there, and I can go on and I can add tags to various other common cut groups of parts. Now if I come into automatic order will now support these common cut tags. Duplicate cuts for foil cutting on sheet scrap cuts and offcuts. It is now possible in auto tooling to add duplicate cutting automatically to both sheet offcuts and scrap cuts. Punching. Floating scrap detection. A great new feature has been added to punching in order to detect floating scrap on. To make sure the NC program that is made doesn't create floating scrap on the machine tool, a new check can be run in order mode. The function can be started from the order menu. The software will then analyze the individual hits in the job and see whether any floating scrap appears at any point. Floating scrap becomes dangerous if it is not subsequently removed using a machine stop shoot or pick operation. The software then highlights the lines in the order text that produce the floating scrap. When the line is selected, a message shows details about the first piece of floating scrap that is generated. Okay, this is well worth a look. So I've got a project which has got some components in which I have deliberately put some floating scrap. So let's see if we can detect where that floating scrap is. So on our first nest, we've just got a large single part. If we go into order mode, in order mode, we can select detect floating scrap. Now you can see here we've got 3 warnings indicating that there's 3 areas that we need to look at. Down in the order text, the line concerned has gone red. We can select on that and then we get a big red rectangle indicating where the floating scrap is. And you can see here that's the tooling that's going to create that piece of floating scrap. If I select the next one in the list, it's got a tiny little red cross which when zoomed in becomes a little red rectangle which describes the area of the floating scrap, and there you can see that tiny little triangle which is in actual fact going to be floating when we punch this component. Moving on to the next nest, again what we can do is we can go into order mode and we can check to see where the floating scrap may occur. In this case we've got 2 warning messages, so again select the red text in the order text and there you can see a big red rectangle indicating the area that will float once we hit the final punch blow. Again a tiny red cross indicates a small area of floating scrap, and as we zoom in the rectangle is described and you can see there that that piece of material will actually float when we hit the final punch blow. Nest projects. Nest project reports. Following on from setup sheets, the Nest project reports can now be easily designed using the new report writer that is included in Radan CAD/CAM. Access to the Nest project reports is via the same icon as previously. The reporting engine has been designed to be future-proof and may contain some terminology that is different from what you are used to. In general, the information that is available is much richer than before and allows for comprehensive, multifaceted reports to be created in minutes. The new style reports will replace the current PDF reports, which will no longer be supported as of Radan CAD/CAM 2018. Okay, let's take a quick look at some Nest project reports. So to access them, it's the same way as before. Use this icon here to run the Nest reports. And here you can see a typical Nest report. Now to edit the report, you simply come up here, go File, Edit, and this takes us into the new report writer. The new report editor has access to a range of Radan attributes and information, and therefore will allow us to generate some really rich content reports very quickly and very easily. Nest project templates. To make it easier to create new Nest projects with settings that suit the upcoming task, a Nest project can now be saved as a template using the Project Properties dialog. When creating a nest project, simply initialize from a previously saved template. Your project templates are stored in your Radan DAT directory in a subdirectory called Nest Project Templates. General CAM nesting. The true shape nesting engine RadNest has been further enhanced, typically where a low number of different parts are concerned. In these cases, where the nester has fewer options to combine, the nester now tries more orientations, which can result in a higher material yield. To demonstrate this, we have two nesting examples. Here in example 1, we have taken a component and nested it in Radan 2016. And as you can see, we can get 25 components from a sheet with a utilization of 41.9%. If we take that same component and we nest it in the enhanced nester of Radan 2017, you can see that we now have 27 components with a nest utilization of 45.3%. Here in nesting example 2, we have nested 3 separate components, and of component 1 we can get 30, 6 of component 2 and 25 of component 3, with a nest utilization of 63.4%. Again, taking those 3 components and nesting them in the enhanced nester of Radan 2017, we see the following results. We get 30 of the first component, we only get 4 of the second, but we get 27 of the third, giving an increased utilization of 65.3%. General CAM, Automatic Order Style Editor. Automatic order styles can now be configured using a new easy-to-use dialog instead of plain text. The new editor is the default option for modifying auto-order styles. The text editor can still be accessed if required. The dialog has a clear layout and uses right-click, drag and drop to configure an auto-order style. Here on screen you can see the new auto-order style editor. Let's have a look at this new editor in action. So here in order mode, I'm going to open up an auto-order file using the new editor. And hopefully you can see it's a nice, easy to view layout. Very quick and easy to amend and add new lines to your auto order file. As a comparison, I'm going to open up this same auto order file in the old editor. And there it is, using the old editing mode, which is still available if you prefer to use this. General CAM, Material Selection. The dialogues used to select materials have been enhanced. The list boxes are now resizable, and optionally the tree view can be used when creating a new part. So there you have it. If you'd like more information about this release, then check out the release notes on your install DVD or go to the Radan website.